All right, so let's find the centroid, the center of this region, bounded by cosine of x, y equals 0. So cosine of x, y equals 0, x equals 0, and x equal pi over 2, which is right here. So it's going to be somewhere in there. All right, so first I'm going to find the mass of the area that's bounded that I'm using. So that's going to be the integral from 0 to pi over 2 of cosine of x. That's going to be nice and easy. Sine of x between 0 and pi over 2. Well, that's easy. That's just 1. Okay, so let's go find the x bar. So x bar, let me just write the formula down here, is 1 over a, 0 to pi over 2, x, f of x, right? So just writing it down again. So my a is 1, so it's going to be not really anything to worry about. 0 to pi over 2. So x times cosine of x. Well, that's integration by parts, isn't it? You know that's u equal x, dv is cosine of x, du is dx, v is sine of x. Okay, so, whoops, don't need that there. And actually, let me just finish it over here. So I get uv x sine of x minus the integral of v du sine of x dx. I'll leave the limits off just for a second. I'm finishing everything off. Take the antiderivative here. I get a positive cosine. Now I'm plugging in 0 and pi over 2. So I plug in pi over 2. I get pi over 2 minus 1. Okay, so that's my x bar. So now let's go find my y bar. So my y bar is 1 over a, 0 to pi over 2, just writing it down again. So it's 1/2 the function squared. So the function is cosine of x. So the a is 1, right? So I'm going to pull this 1/2 outside. And I know to take the antiderivative of cosine squared, I need the half angle formula. You're familiar with that. You got to know everything all the time. So 1/4, right? These two 1/2. So now I'm ready to integrate 1 and get x. Integrate here, 1/2 sine of 2x between 0 and pi over 2. So plug in the pi over 2, and the only thing I get is that pi over 2 right there. So I get pi over 8. So my x bar, y bar is pi over 2, pi over 2 minus 1, comma, pi over 8. All right, so moving on to another generalization. What if the area is that I'm finding lies between two curves? So there's the curve up here and a curve down here and some edges. So I want to find the area between them. So in general, the formulas are the same. So it's x times, and then it's f of x minus g of x here instead of just an f of x. And then this one, we take 1/2 the f of x squared, subtract the g of x squared. So we square each of them individually, and we still have this area down in the bottom, which is the m. So just a little bit more for the integrals. So let's finish it off. We've got a time here. So the mass will be, so let's make sure we know what we're looking at. Y equal x squared, y equal x, right? That area right there. So integral from 0 to 1, because I know that's where they intersect. Sometimes you'll have to go solve for things. Top function, subtract off bottom function. You remember that from last semester. So x squared over 2, x cubed over 3, between 0 and 1. So I get 1/2 minus 1/3. So that gives me a 1/6 of the mass. All right, so let's go find x bar. So that's going to be 1 over the a. So 1 over this. So I'm just going to put that in right now. So that's 6. Integral from 0 to 1. And then it's going to be x times this f of x minus the g of x. So you know you have to multiply things like this out first. So I get x cubed over 3 minus x to the 4th over 4 between 0 and 1. And so then I'd get 6 times 1/3 minus 1/4. So that'd be 6 times 1/12 or 1/2. Okay, so that's my x bar. So now what's my y bar going to be? So y bar is going to be 1 over a, so 1 over 1/6, which is 6. So then it's going to be 1/2 times this top function squared, subtract off the bottom function squared. And then from 0 to 1. Okay, so these two things make a 3. And then I'm going to be integrating x squared, so I get x cubed over 3, x to the 5th over 5 between 0 and 1. So I get 1/3 minus 1/5, or 1 minus 3/5 or 2/5. Okay, so my x bar comma y bar will be 1/2 2/5, and that kind of makes sense, right? Halfway this way, and then a little bit less that way.